welcome to another WJEC A-level physics question. This is from Unit 1, January 2008, and it was question 2 on the paper, and it's a question about materials. So first part of the question, we've got a complete stress strain graph for a thin specimen of glass, and it shows the full range of strains possible for this particular specimen. And first of all, we've got to explain why there are no units given on the strain axis. Well, strain doesn't have a unit because it's a ratio of two lengths. So when we have a length, for example, in meters divided by another length in meters, those meters cancel and we're left with no unit. Next, we're asked to determine the Young modulus for the glass. Well, the Young modulus is the stress over the strain. We can read the stress and strain directly from the graph. Might as well use the biggest values, smaller percentage uncertainties involved in reading off the graph then. So the stress is 8, but we mustn't forget that it's actually 8 times 10 to the 7 pascals. I've seen lots of people fail to read the units on the axes of the graph. And similarly, the strain is 1, but it's 1 times 10 to the minus 3. We can see that over here. So this will give us an answer in the end of 8 times 10 to the 10 pascals. We're asked then, is the deformation of the glass shown by the graph elastic or plastic? And we've got to explain our answer. Well, it's an elastic deformation here, because if we remember our stress strain graphs, we always have the limit of proportionality closely followed by the elastic limit, and because this is still a straight line through the origin, it means that the the limit of proportionality hasn't been exceeded, and therefore neither has the elastic limit. So let's say something like elastic because the glass is stretching in a linear way, so the limit of proportionality hasn't been exceeded. Next, we're asked to state what happens at point P. Well, this was the complete range for the graph, the full range of possible strains. So what happens at point P is that the glass will break, the glass will shatter. Remember, the glass is a brittle material which behaves elastically and has very small, if any, plastic deformation before it finally breaks. For B part 1, we're told that glass is a brittle material, and we've got to briefly describe the process by which glass fractures. So brittle materials fracture because of concentration of stress at tips of cracks. So let's say something like at the tip of a crack, a surface crack here, there'll be a concentration of stress. Now what will happen then is any bonds at the tip of the crack will find themselves experiencing too much stress and will break. That means that the stress is then passed on to the next bond underneath. And that bond will break, and so on. So the crack will propagate very quickly through the glass. Car windscreens for part 2 are made from pre-stressed glass. So during production, jets of air are used to cool the hot glass, which cools the outside to contract and harden, while the inside remains soft. Later on, the inside cools and contracts, pulling the outside surfaces under compression. Explain how this procedure makes the windscreens less likely to fracture. So what we're looking at here is that the compression squeezes cracks closed. and therefore there's no concentration of stress at the tip of the crack, and therefore the bonds at the tip of the crack don't break, and therefore the crack doesn't propagate. So we can just simplify this at the end and just say something like, therefore cracks won't propagate through the glass. Thank you for listening. Please remember to like and subscribe, and ask any questions you like in the comments that go with the video. Goodbye.